Hey everyone, and welcome. Today, we're going to crack open the digital filing cabinet of your computer. We're talking about the hardware that saves, well, everything, from your vacation photos to your most important work. Yep, we're diving into computer storage devices.
You know, it's such a simple click, right? We do it dozens of times a day without even thinking. But behind that one little action, there's this incredible world of technology designed to remember every single thing you tell it to. So where does that file actually go? Let's find out. Okay, so to really get this, it helps to think of a computer's memory kind of like our own. You've got your short-term memory, think of it as a workbench for whatever you're doing right now. And then you've got your long-term memory, like a big, sturdy filing cabinet for everything else. Well, in a computer, that workbench is called RAM, and the filing cabinet, that's exactly what we're talking about today, the storage device.
So you might be asking, why can't a computer just use its workbench for everything? I mean, it's right there. Well, it has one major flaw, a problem that led to the invention of all the storage devices we rely on today.
And here's the problem. The computer's main memory, its RAM, is unbelievably fast. It lets your computer just zip through tasks. But it's also volatile, and that's the key word. The second you turn off the power, it gets total amnesia. Everything you were just working on, poof, gone. That's a pretty big issue if you ever want to see your work again, right?
And that's where the storage device comes in to save the day. It's a piece of hardware built for one crucial job, to hold on to your data for good. The magic word here is non-volatile. Power on, power off, it doesn't matter. Your files, your photos, your games, they're all safe and sound. It's the computer's permanent memory.
So if we put them side by side, it really breaks down like this. Primary storage, that's our RAM, is temporary but blazing fast, and the computer's brain has a direct line to it. Secondary storage, our hard drives and SSDs, is permanent and has way more space, but it's a bit slower. They have to work together as a team. RAM is the busy workbench, and your storage drive is the massive warehouse. So how did we even get from needing this permanent storage to the tiny devices we have today? Well, it all started with magnets. And believe me, this journey is incredible. It takes us from machines the size of a room to something you can slip into your pocket.
The story here builds up really fast. It kind of started with magnetic tape way back in 1928, but the real game changer was 1956. That's when IBM unveiled the first ever hard disk drive, the great-great-grandfather of the drive that might be in your computer right now. After that, we got the floppy disk, which made data portable for the first time. And then IBM's Winchester drive in '73 just set a whole new standard.
Okay, get ready for this, because this really puts things into perspective. That very first hard drive, it was an absolute monster. It weighed about a ton, was the size of 2 huge refrigerators, and it stored just 3.75 megabytes. That's not even enough for one good photo from your phone today. It's wild.
So what is this number? 9.6 million. Well, that number represents the mind-blowing improvement in storage capacity. From that first 3.75 megabyte drive to the multi-terabyte drives we have today, the capacity is increased by a factor of 9.6 times million. That's like going from being able to store a single, low-quality song to storing the entire Library of Congress thousands of times over. It's just staggering.
All right, so while all that magnetic stuff was getting smaller and more powerful, 2 new technologies were bubbling up that would completely change the game. This is where we get into the really modern stuff, focusing on light, electronics, and making things super portable.
So first up, we have optical storage. Instead of magnets, these things use a super precise laser to read and write data. Basically, the laser looks for these microscopic little pits and flat spots on a spinning disk, and that's how it translates them into the ones and zeros that make up your files.
And you definitely know these. We started with the good old compact disc, the CD, for our music. Then came the DVD, which could pack a whole movie on one disc. And finally, Blu-ray came along, pushing the capacity even further for all our high-definition shows and movies.
But honestly, the real revolution, especially for personal storage, was flash memory. This is a whole different beast. It stores your data completely electronically, using millions of tiny little transistors. And here's the crucial part. There are absolutely 0 moving parts. None. That makes it incredibly tough, way more power efficient, and so much faster. And flash technology? Oh, it is everywhere. You've got the humble USB drive that made sharing files a piece of cake. The tiny SD card became the heart of our cameras and phones, and the solid-state drive, or SSD, took that same tech and used it to totally reinvent a computer's main storage.
Okay, so this brings us to today, and to the main event, really.
This is the big choice most of us face when we buy a computer, the battle between the old guard and the new challenger.
On one side, you've got the classic, the old workhorse, the hard disk drive, the HDD. It's this mechanical marvel with an arm flying over spinning metal platters. It's been around forever, and it gives you a ton of storage for your money. And on the other side, the solid-state drive, the SSD. This thing is pure electronics, no moving parts, which makes it way faster, way tougher, and totally silent.
So, what's the big deal for you? Why does any of this matter? Well, switching to an SSD is probably the single biggest upgrade you can make to your computer. Your whole system will start up in just a few seconds. Programs launch instantly. The entire experience just feels so much faster and more responsive.
And of course, we can't talk about modern storage without mentioning the cloud. Now, cloud storage isn't really one device. It's a massive network of servers in huge data centers all over the world. You're basically just renting a tiny slice of a giant, professionally managed storage system that you can get to from anywhere with an internet connection.
So where do we go from here? I mean, hard drives, SSDs, the cloud, they all feel pretty futuristic already. But researchers are working on the next massive leap. What if we could encode all of our digital data into the building blocks of life itself? We're talking about DNA. It's already happening. It's a technology that could potentially store unbelievable amounts of data for thousands of years. The ultimate filing cabinet might just be biological. Now that is something to think about.